So when we're taking the differential, or rather the derivative of a natural exponential function, okay, so the natural exponential function is e to the x. Okay, so we're taking the derivative with respect to x of the function e to the x, okay, the natural exponential. Okay, and it turns out that because exponentials are so awesome, the derivative of an exponential is the exponential itself. Okay, so the derivative of e to the x is e to the x, but of course because of the chain rule, we have to multiply by whatever the derivative of that power is. So do not forget to do the chain rule for every one of these exponential functions that we're going to be taking the derivative of. Okay, so let's jump right in here. Our first function is e to the sine x. So when we take the derivative, of course we write f prime equals, well, e to the sine x's derivative is just e to the sine x. It is its own derivative. But then we have to multiply it by the derivative of sine x, which is cosine x.
Wait, isn't it outer than inner?
So when we write this in a more standard form, this becomes cosine x times e to the sine x. Okay, so that's the derivative of e to the sine x. Okay, times there. Okay, let's see what else we have. Here is a function e to the 2x plus 3 power. So once again, we have a chain rule. We have to take the derivative of e to the 2x plus 3, right? So this is your inner function, and e to the x is your outer function. So the derivative becomes, that's f prime, e to the 2x plus 3, right? It is its own derivative, times the derivative of our power. So the derivative of 2x plus 3 is just 2. So if we do a little bit of rearranging of our furniture, we have 2 times e to the 2x plus 3 as the derivative of e to the 2x plus 3. Okay, let's move down on the page and look at this function. We have in parentheses 2x plus 3 times e to the 3x. So the first thing we're going to do is apply the product rule to our derivative. Okay, where 2x plus 3 is your f function, and we will call e to the 3x our g function. Okay, so we're going to apply the product rule, which means we have f prime times g plus f times g prime. Okay, and of course you can do these in the opposite way if you want to, as long as you're multiplying one derivative times the other function, and then the other function times the one derivative. Okay, so this is applying the product rule to begin with. So in this color, what is the derivative of 2x plus 3? That's just 2. So the derivative of f, or f prime, is just 2, and we multiply that by e to the 3x plus our original f function, which is 2x plus 3, times the derivative of e to the 3x. Okay, so when we're taking the derivative of e to the 3x, it is itself times 3. Okay, so is itself, and then you have to multiply it by the derivative of the exponent. Using the chain rule, right, this applies the chain rule in order to take the derivative of e to the 3x. Okay, so let's see what we have. Now we have to do our algebraic simplification. So this is 2e to the 3x, that's not too bad, plus 2x plus 3 times 3e to the 3x. Right, you put the number in front of your exponential is the traditional way of doing that. So now we're going to do our algebraic simplification and distribute our 3e to the 3x to both of our terms here. Okay, so we still have our 2e to the 3x. So 2x times 3 is 6x e to the 3x. plus 9e to the 3x. Okay? So now we have some like terms. We have 2e's to the 3x and we have 9e's to the 3x. When I add those together, I get 11e to the 3x's plus 6xe to the 3x. Okay, and then the last step in our algebraic simplification is to notice that both of these terms are multiplied by e to the 3x.
So you just take out e to the 3x.
So we are going to factor e to the 3x out of both of these terms, and I end up with 11 plus 6x times e to the 3x. Okay, all that algebraic simplification to get this nice, handsome little answer. Okay, let's use some more chain rule with our function square roots of e to the 2x minus 6. So we're taking the square root of e to the 2x minus 6. So if you remember anything about your roots, your derivatives, the derivative of the square root is 1 over 2 times the square root. Okay, this is always a derivative of a square root function. Now, we have to leave what's underneath the radical. So 2x minus 6 is still underneath the radical. Now, we have to use the chain rule and multiply by the derivative of e to the 2x minus 6. Okay, which is also a chain rule question in and of itself. So the derivative of e to the 2x minus 6 is e to the 2x minus 6 times the derivative of 2x minus 6, which is 2. Okay, so we apply the chain rule to every exponential problem that we have. We have to multiply our function by the derivative of the function. The outer is the square root, and the inner is e, and the inner is 2x minus 6. Okay, so now the algebra begins as we simplify this. So this is all numerator, so this goes into our numerator. Okay, so 2e to the 2x minus 6 over 2 times the square root of e to the 2x minus 6. Okay, so look what we can cancel out. We can reduce this by doing 2 over 2. That's 1. Okay, so now we really shouldn't leave a radical in the denominator. So we're going to multiply by e to the 2x minus 6, top and bottom. So what happens in the numerator is we have e to the 2x minus 6 times this root of e to the 2x minus 6, all divided by e to the 2x minus 6.
So those can cancel out, right?
So these will divide each other out, and we get the square root of e to the 2x minus 6. That was exactly what we started with. It is its own derivative. What is going on there? Okay, so now if you look at your photomath, which I know you do, okay, photomath will continue, and it will factor a 2 out of each of these, right? There's a multiplier of 2 times x, and there's a multiplier of 2 times 6. So what we have created now is a perfect square, right? We have e to the square, and we're taking the square root of it. So the square and the root cancel each other out, and our final answer, according to photomath, would be x minus 3. And if you don't pay for the version, they don't tell you how to get this. And your math will not be very good, because your teacher, I'm sure, is going to want to see it, and photomath won't tell it to you.